Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of writing exponential functions, specifically writing them from tables, and we will do it in 5 minutes or less. So sometimes we are just given a table of values and we are supposed to write an exponential function. So how exactly are we supposed to turn this table of values into an exponential function? Well, let's look at our standard form here of your exponential function. So y equals a times b to the x. So what are each of these terms? Okay, so a is going to be your different things depending on what you're looking at. It could be your principal if we're looking at like compound interest. Another way to think of it would just be your starting amount. All right, so what are we starting with? And if we're dealing with tables and graphs, the easy way to figure that out is to look for your y-intercept, because your y-intercept is where the graph crosses the y-axis when x equals 0, and that's your starting amount, is when your x is 0, because this x is going to be your time frame. So weeks, years, months, whatever the time frame is, because we're multiplying it by that's the exponent. So we're looking at when x is 0, when it's the starting time, what is that y value? So b here is going to be your growth if it's increasing, or decay if it's decreasing factor. And that's a little bit tricky to calculate sometimes, and that's usually going to be the one where we have to do a little bit of math to figure it out. So let's take a look at this. Well, we've got f of x. If we wanted to write this particular function equals, okay, so what's my a? My starting amount. Well, they give it to us right here. My x equals 0. My y-intercept means that my f of x, or my y value, is 200. So I'm starting with 200. And then what they did is they took it back in time, and then they took it forward in time. We don't know whether it's years, months, weeks, days. It doesn't really matter. So all I need is my growth or decay factors. How do we find that? Okay, so what we do is we take each of these y values and divide it by the previous one. So watch this. So I'm going to take, I'll start with my 2. So my 112.5, divide that by the previous value, 3/4. What happens if we do 150 by 200? Well, guess what? It's a function, it's constant. It's going to be 3/4 as well. So that's going to be our decay factor. We can call it 0.75. We can keep it as a fraction, but it's going down by 3/4. If we're moving backwards, we take each of these y values and we divide it by the previous one, and then x is going to be our time. So that's how we would write this particular function. So we have a new set of values. We're still wanting to write it in this exponential form, y equals a times b to the x, but we don't have a y-intercept right here, at least not on the table. So what we need to do here is we need to back this up here. So we need to go ahead and first find the b in this situation. So let's find that growth or decay factor. So let's just take 67.5, divide that by 45, and that is going to give us our b, our growth factor, and it is getting a bit bigger here. So if we divide that, it's going to be 1.5. Okay? So then we need to back that up, right? We need to take our 2 and we need to find, well, what happens when x equals 1 and then x equals 0? Well, we know that 45 divided by the previous number, which I'll call c here, equals 1.5. So we need to multiply both sides by c to get that out of the denominator. So it's 45 equals 1.5c. So basically what we're doing is we're just dividing both sides here by 1.5 to get that growth factor out of there, and that's going to be 30. All right, so x equals 1, well then y equals 30. Then let's do that same thing. Let's take our 30 divided by 1.5, and that's going to get us 20. That's what happens when x equals 0. So that is my a. So y equals 20, my growth factor, 1.5 times x. That is my function.